I'll share my screen now. Can you all see my screen, right?
Yes, sir.
For today's class, what we are going to do is I'm going to demonstrate uh, normal static analysis using 1D problem. Okay, in college and all, we are solving mm, most of the problem related to shape versus minimum diagram. Whenever we are dealing with 1D element, right? We mostly on not only that, even if you are applying for any competitive exams and all, you will be seeing that one problem will be coming from Schaeffer and minimum diagram. Okay, so we studied those things in engineering. Okay, now we are going to solve the same problem in using Ansys, as well as not only that. For example, if you are having three-dimensional structure, like we are not we are using Ansys not only for solving a simple problem. We are sometimes we are dealing with higher level problems, right? In first classes, while creating a geometry session, right? In that I created one chair. Okay, that is stool I created, right? In that stool, you are not only analyzing that stool entirely as a three-dimensional. Okay, you have to convert that three-dimensional structure into two-dimensional or one-dimensional. For example, hope you remember that tool structure, right? That plate you have converted into 2D, and the legs and all you have to convert it into one-dimensional element. Okay, like that you have to convert those whole structure into 1D and 2D. Sometimes you have to analyze the whole structure as a three-dimensional. Okay, so in today's classes, what we are going to do is I'm just going to teach you how to perform a normal one-dimensional analysis and how you to convert that 3D structure into 1D element, like 1D structure. Okay, normally you have 3D three-dimensional structure is there. How you convert those three-dimensional structure into 1D, and how you going to perform the analysis. And if you want to calculate the shape force and minimum diagram for particular beam or for particular one-dimensional structure, means how can you able to perform those things, and how can you get the result from this Ansys workbenches. Those are the things only I'm going to cover in today's classes. Okay, not only that, um, I'm explaining in both ways, how to create a geometry in space climb, as well as I will be touching the designer model workbench also. Okay, what was the difference between those things? I'll do those things. Okay, so as of now, you see this is the workbenches, and I taken the static structural. Okay, I'm going to create a geometry. That is in geometry. I'm going to right click and click on space climb, because I'm going to create a geometry over here. Okay, for the problem I'm going to take, here it is. I'm just taking the normal cantilever beam itself. Okay, in the cantilever beam, what I'm going to do is I'm going to create a cross section is different. That is the Z cross section I'm going to take. Okay, I'm going to take the cross section of this beam is Z section. Okay, I'm going to take this type of cross section. Okay, and I'm going to analyze the structure. That is, I'm going to take this is 1000 mm, that is 1 meter length of the beam. Okay, I'm going to solve this problem. Only difference is I'm not going to create a line element here over here. Okay, in that first classes I demonstrating how to solve the problem in 1D level. For that I created the line element, right? So for today's classes, what I'm going to do is I'm going to create a three-dimensional model of this uh, beam structure, and I will demonstrate how to convert that 3D into 1D. Okay, so for this, what I'm going to do is you can see this, as soon as you open this space climb, you get this type of window. So I'm going to draw a cross section in XY plane. Okay, you can see that plane now it is in ZX plane. I'm going to convert that two-dimensional plane in XY plane. So I'm going to here in this, I'm going to select click on this. So I get the view of XY plane. So in this I need a sketch view. So that I'm going to click on this sketch plane here and hover over this and click on this, so I can get this type of grid option. Okay, so in this here I'm going to create this cross sectional. So I want to create this cross sectional length over here in this grid. Okay, for that I'm going to click on this line option. Okay, so here I'm going to click on the line option. I'm going to create one line over here. That is, I'm going to take as a 15 mm and 2 mm, like that I'm going to create. Okay, so I created this type of user section here. Okay, so the dimension is, you can take the dimensions, like I am taking the dimension is, this is 15 mm, this is 2 mm thickness, and center the web will be 4 mm thickness, and this length is 15 mm. Okay, this is how I'm taken this dimension. Okay, so once you draw the required dimension of the cross sections, what you have to do is, normally we have to pull, right? We are using the pull option. Okay, if you want to increase the thickness, like I'm just to click on this and just simply drag, and for this I'm going to create a value is 1000 mm, because my length of this beam is 1 meter, right? So I'm just giving 1000 mm. I am press enter. Okay, so now I created a three-dimensional structure. You can see this in that structure. The solid element is created. Okay, so this is a solid. It's not a one-dimensional element. Okay, uh, so now I'm going to convert this three-dimensional structure into 1D. Okay, normally in first classes, what I taught you is like I created a line element, and then I created the in sketch I created only a line, and after that I just went to the prepare, and then where we have created the cross sectional area and all. Okay, so you can see the this type of cross section only you can able to create. So you can see that Z cross section, some other cross section is you can able to predefine the cross section is here. Okay, uh, like that you have to do it. Okay, in first classes I demonstrated like that. Okay, and after that you assign the cross section over the line element, and you have to convert that line element into beam element, like that only you did it. Okay, but now what we are here we have to do is, like we have that solid structure now. Okay, in solid structure I'm going to convert this solid structure into one dimensional structure. For that I'm just switching over the prepare option. You can see this option called the extract, right? So you can see that whenever you hover over the extract, there is an option, it shows extract a beam from a solid. Okay, so you click on this extract option and just click on the solid itself. As soon as you select the solid, what happens, it convert that 3D element into line element. Okay, and you can see that beam element is already created, and the cross section is extracted profile is created. Okay, so you can see that cross section of the extracted profile. If you click on edit beam profile, you can see that the cross section is automatically taken over. Okay, no need to create extra cross section over here. Okay, so here you already have you created a three-dimensional structure. Okay, and you simply click on extract and click on the which solid element you want to convert into 1D element. You just simply click it. Okay, the software itself will convert the whole structure as a line element, and it assign the cross section based on the dimension you, it is assigned as a solid. Okay, it is automatically assigned. I can see that in that structure tree the solid element is suppressed. You can see that symbol, that is one circle, and it crosses, right? It indicates that it is solid is now it is suppressed. That is while converting the structure into for analyzing purposes, the solid is not considered for analysis. Only this beam and that cross sectional area is used for analysis. Okay, up to this it's clear, or do you have any doubt? Clear, right? Or I'm moving fast? Okay, thank you. Okay, now we created this one dimensional element. Okay, so once you open created, you can simply close it, exit from space climb. Okay, so in that workbenches, you will double click on the model, the mechanical workbench will open. Okay, in mechanical workbench you can able to analyze the structure. Okay, now you can see this in the problem statement. We created the length of beam as a 1 meter we created, and we created the cross section in that is solid element, and we convert that solid into 1D element. Now as of now we completed only the geometry structure alone. Okay, so in mechanical workbenches, once it's all it is automatically imported here. Okay, so here I'm going to calculate the shear force and bending moment diagram for this beam. So okay, for that what I am going to create is I want to create a path. Okay, for which point to which point you are going to calculate the shear force and bending moment diagram. You have to define those starting point and ending point over here. Okay, for that I'm going to right click on the model, insert. Here you can see the construction geometry, right? In construction geometry you have to click on path. Okay, once you click on the path, you can see that the path type is 2 points. Instead of 2 points you have to convert it into edges. Okay, and you select the edges because this is the length I am going to perform. So I select on this edges and click on apply over here. You can see that in geometry one edge is selected here. Okay, and you can see that number 1 and number 2 is specified here. Okay, that means that edges start from point number 1 and point number 2. Okay, so the shear force and bending moment diagram is calculated from this point to this point, it is going to calculate. Okay, so this is very important. And then I'm going to apply the boundary condition over here. So for cantilever beam it is one end is fixed and another end is load I have to apply. Okay, so here in insert I'm going to apply a fixed support. I'm going to apply fixed support at point number 1, that is at this vertex I'm going to select and click on apply. So in geometry one vertex is selected. Okay, so I'm fixing this first point and I'm going to apply a load. Right click on static structural, insert, and you click on the force, and here you can apply the this vertex point. You apply the apply. So in geometry one vertex is applied, that is other end. Okay, here you can convert that you can choose the component. Okay, in component y you can see that total geometry structure it is in z axis. Okay, in y axis you can apply the vertical load. Okay, so that means I am going to apply a vertical load in y axis, that is minus 10,000 Newton I am going to apply. Okay, it is downward, that's what I put as a negative. Okay, now I'm going to mesh the structure. So in that mesh you can see in the tree, if you see the tick symbol means it is all correct. Okay, if you see the thunder symbol means it is on process, you are not done anything, like you have to do some updation, it's required here. Okay, so here what I'm going to do is I am click on the right click on the mesh and click on generate mesh. Okay, so the mesh is created. Okay, over the length of the beam, and then in solution I required shear force and bending moment diagram, right? So right click on the solution, insert option, you can see the beam result, right? In beam result you can see that in bottom the shear force and bending moment diagram is there. Okay, you click on the shear force and bending moment diagram. Okay, as soon as you click on here there is a question mark is here, that means you have to give some input over for this solution. So you have to specify the path. Okay, we already created the path for this purpose only. So here in the path you click on the path is path 1, because that is this path you have to select. Okay, once you select the path you can see that that is point number 1 to point number 2 is selected over here. Okay, so for point number 1 to point number 2 it calculates the shear force diagram and bending moment diagram. Okay, and if you want to calculate the reaction forces also, you can able to create the calculate the reaction, that is a right click on the solution, insert, in probe option you can see that force reaction. Okay, for example if you want to calculate the reaction about the supports, you can able to calculate, you can get the result of that reaction forces, that is if you click on the reaction here, force reaction. So it asks at which point you want to create you want to find the reaction force, because at point 1 only I'm fixed the geometry. Okay, so I want to calculate the reaction forces, that is vertical reaction I want to know. Okay, so here you have to specify the fixed support. Okay, so I done those things, and I want to calculate the deformation also. So I right click the solution, insert deformation, that is total deformation. Okay, so these are the things I required. I'm going to solve this problem now. You simply click on solve option. Okay,
Yes, sir.
so you can see that solution is solved now. You can see that first thing is shear force bending moment diagram. Okay, once if you click on the solve option, you can see that some in background will solve. Okay, it will goes to up to 100%. Once it's solved, you can see this type of result here. Okay, as soon as you click on this shear force bending moment diagram, you can see that the first bar here, it is a shear force. You can see it start with 0 and goes to maximum is 10,000 and end with 0. Okay, you can see the bending moment here at point number 1. uh, we applied the fixed support, right? So this is the point number 1, this is point number 2. Okay, so the bending moment is maximum at the fixed point. Okay, so this is point number 1 and point number 2 is the right hand side. Okay, so this is how it is shown here. At point number 1 we applied the fixed support here. So the fixed support, you have the maximum bending moment is 1 into e power minus plus 7. Okay, you can see that even if you calculate the uh, in structure. Okay, so here only we applied the forces, right? We applied the forces here, and we at point number 1 we applied the fixed support. Okay, normally if you calculate the moment means for force center perpendicular distance, here the force is 10,000 Newton. Okay, and here the perpendicular distance is 1000. Okay, so 10,000 into 1000 you get the 1 into 10 power 7. So that was the moment is shown here. Okay, and if you calculate the displacement, you can see at point number 1 it is fixed support, so there is no deformation is present here. At slightly goes to point number 2, the maximum displacement is it is 1362.9 mm. Okay, since we applied the larger things, we have larger deformation over here. Okay, so this type of deformation is not acceptable. Okay, so this is nearly what 136 centimeter uh, deformation. Okay, even if you want to calculate the stress also, you can go able to calculate. Okay, so even if you calculate the reaction, if you click on the reaction, you can see that this is where we apply the fixed support, right? And fixed support, that is the whole cross section is fixed here, it is shown here, and reaction is upward direction. Okay, okay, so here we applied the force in downward direction, so reaction is in upward direction. So the reaction force is here, it is total reaction is 10,000, we applied force is 10,000, so reaction also 10,000, so that's also equal. Okay, so this is how you can able to calculate what are the result you can able to get it from beam, you can able to get it. Okay, so this is one thing, and one more thing here it is I want to demonstrate here. It is like if you open space climb, normally what we do is like we click on the workbenches and we go towards the static structural, right? Okay, and then we create a geometry over here, and then we go to the mechanical workbench and we select the analysis. Okay, this is one method we do. Okay, normally you directly open space climb. Okay, as soon as you create a because I here I didn't create any workbenches, I didn't created any analysis system. Okay, without creating the workbenches and without selecting any analysis system, what I did is I directly opened the space climb. Okay, and then if you want to perform any geometry, like I'm going to create a geometry over here. Okay, So I'm going to create as 15 more 15. So I created geometry here and using pull option I'm creating this geometry. Okay, now I created this three-dimensional structure. Okay, now I'm going to consider I'm going to convert this as a 1D. Okay, by click on the prepare option, click on extract, just simply click on the solid structure, so it converted into 1D. Okay, from here itself you can directly go to workbenches. You can see that workbenches right in here. In workbenches we can click on workbenches also, or if you want to directly go to the mechanical workbench also, you can click on mechanical. As soon as you click on mechanical, it asks you to save this geometry name. Okay, for this I'm going to give the name is uh, 1D beam. Okay, I click on I just give the name and click on save option. Okay, so the geometry is saved in that particular location, and then it will start opening the mechanical workbenches. Okay, and in that mechanical workbenches, whatever the geometry we created in the space climb, it automatically converted into there. Okay, but one thing is uh, so you can it create new workbenches, and it will create the mechanical workbenches also, but it won't we are since we are not setting up what type of analysis system we are going to perform, right? So in this mechanical workbenches it won't show static structural and all. Okay, so you can see that now the mechanical workbench is opened. Okay, and new workbench is also open here. In that workbench you can see that only geometry and model is there. Okay, there is no what are the analysis we are going to perform, it is not shown here. Okay, because from the space climb we directly select only the mechanical, so it can transfer all the component here, the geometry here in the mechanical workbench alone. Okay, so here we are not adding any analysis system. Okay, in mechanical workbenches if you want to add the analysis system you can add it. Okay, that also I will explain here. So what we do is I'm going to mesh the structure. So if you click on the generate mesh, the structure will be meshed here. Okay, and I'm going to add the analysis system over here. So for that I'm going to go for home option. You can see in the home analysis is there, right? Click on this analysis. You can see here you can perform different analysis system. Here it is. Okay, so I'm going to perform static structural, so I click on static structural. So as soon as you click on static structural, that static structuralist component will be here. You can open, you can check it here also in workbenches also. You can, if you click on workbenches, normally uh, previously we can see this only. Okay, now we have the analysis system is open here. Here the geometry we created in the space climb is shared here, and whatever the mechanical workbenches, that is mesh we created, right, that also shared here. Okay, so now we can again we can perform the same thing, like we can apply the load and boundary conditions, and we can apply the what are the result you wanted, and you can able to solve the problems like that. This is one option, that is from space climb you can open the other thing. Okay, it's clear. This option is clear, right? That is okay. So one more thing I want to demonstrate here it is like you can see whenever we create profiles, right, that cross section of any structure, you can see only this type of cross section is available, that is I section, T section, Z section is there. Okay, L section is there. Here you can see that only Z section is in this way, normal Z sections. So what we created here it is that Z section is in this way, inverted Z section we created. Okay, if you want to create some other cross sections, okay, even if you created the cross sections here, you want to change the orientation. Like for example, I'll demonstrate that also. I'll close this workbenches space plan. I'll create so you can see that this uh, so normally what I'm going to do is I'm going to create a line over here. Okay, so I'm going to create a line as 1000 and 2000. So I've created this line, two lines I've created. Okay, and then in prepare option I'm going to create a cross section for this. Okay, I'm going to create a cross section is I'm going to create a cross section L section. Okay, so in L section I want to demonstrate I'm going to give this value. So you can see width is 100 is taken, thickness 1 is 10 mm, thickness 2 is 10 mm, and W1 is 100. If you want to change this dimension, you can change the dimension. Okay, yeah, if you this is fine means you can go to design itself. Okay, so now this cross section what we are assigning here, it is you want to assign here for this beam. For that you have to create beam line. So click on this edges. Okay, click on create option, you click on this edges. Okay, you can see this type of dotted lines, that means the beam is created. You can see in the under the beam uh, first length is line is L is assigned, and second length also L cross section is assigned. Okay, if you want to see the solid beams, like if you want to see the cross section means you can click on the solid beams. You can see that solid beam is, you can see in this design option, you can see that the L cross section is assigned in this way. Okay, but you don't want this type of L section, you want to change the orientation means in prepare the same thing. You can see that orientation, right? Click on the orientation. And here if you want to change the orientation here means you can, here you can change it in this way. Again you click on this, click on orientation, and click on this required direction. Okay, like that you can change the orientation. So this step is clear. Okay, normally by default what will happen is, like the I created the L section. The L section is uh, by default it shows us in this way. Okay, I converted this L section in this cross section into in this way. Still this is not sufficient means you want to change it means you can click on this orientation and click on this beam, and you can again rotate it over here. Okay, so you can click give this dimension also, how much you want to create. Like a 90-degree means you can create 90 and click enter, so it will convert into that 90-degree rotation will be done. The same goes to here, so you can give that 90, press enter. Okay, so based on your desired orientation you can able to change the orientation of the beam. Okay, so after that here one very important here it is, like since we are taking two length, right? So if you go for analysis purposes you get uh, problem error. Why? Because here we have one element, one length is there, and here we have one length. So this is at this point this is the joining point of these two. So you have to convert this into one whole component. Okay, for that what you have to do means you click on the beam, you select this both beam option. Okay, move to a new component. You have to click on this move to a new component. That means the component will be created. Under the component one, this two beam is there. Okay, not only that, click on the beam component. Here you can see the share topology, right? In the share topology, by default it is shown none. You have to convert this into share. Okay, if you are not done this process means you will have that error code in while solving the problems. That is the pivot error. Why? Because for this length also one node will be here. Okay, for this length also one node will be here. At this point two node will be present at the same point. So one duplicate node you have to remove it. Okay, so if we give the share option, what will happen means that two nodes will come to one node, that is it will merge into one single node. So whatever the load you applied here, it will transfer to the whole structure. Okay, whenever you're creating the multiple line and you're joining the multiple beams together means you have to convert, you have to give this point, that is share topology you should give. Okay, this is very important. If you are not giving the share topology means you will run into some problems. Okay, it is clear.
Yes, sir.
Okay, I will show also what type of problem it is. You can see that now as of now I'm not giving share is none. Okay, so now I'm going to workbenches and opening the mechanical workbenches. Okay, for this I'm giving some value. See, as of now in component I just given none, that is a share topologies I just given as none. Okay, okay, so now geometry is coming. You can see that two lines is there, right? This is line number one, line number two. You can see that different color is there. Line number one is pure white color and line number two is the gray color, right? If I click on this generate mesh, you can see that two line one is having different color mesh and line two have different mesh color. Okay, if you find this type of thing means that is this component is not shared properly. Okay, and you will run into some problems. Okay, so now what I'm going to do is I'm going to simply close this work module. In these things I'm going to click on this component, make a share. Okay, I'm going to save this option and exit this line. So here I'm going to update. You can see now I have given the update option. uh, you can see that both are having same color. Now I'm giving the mesh is then done, right? You can see that as soon as I given the topology shared option, you can see that whole, that length 1 and length 2 having the same color. That means now it is shared. Okay, now you see the difference, right? Okay, so this is very important. if you're not giving the shared topology means, even though if you are giving all the input properties, due to this uh, two nodes at the same point, okay, you will run into some error. So the solution, you won't able to get the answers. It will show some error messages. Okay, so you have to convert this option. You should, in the space climb, you have to give that, you have to make the two beam is under one component, and in the component you have to specify the share option in topology. Okay, then only you can able to ignore, omit this type of error. Okay, so hope you all understand that. In today's classes I just demonstrate how to create a 3D structure in space climb, and how to convert that solid element into one dimensional geometry, and then how to calculate the shape force and minimum diagram. Okay, as well as I will explain that even if you are creating multiple joints or multiple beams, uh, you should give the share option, otherwise you won't get proper result. Okay, so what I suggest is, like, you in engineering, you'll solve a lot of shape for minimum diagram. Like, you solve for a cantilever beam, you solve for a simply supported beam. Okay, if you want to apply simply supported over beam, here means, like, in home option you can go for analysis static structural. Here one support at one end is hinge support, right? You can, here it is, you can see that there's option is here simply supported itself. Okay, you click on simply supported and click on this two edges and click on apply. Okay, so now two vertices selected. Okay, both are simply supported. Okay, so now we apply the forces and you can run it. Okay, not only this, and you solve for you can able to solve for continuous beam also. Okay, for continuous beam and for simply supported beam, you try this and you give different cross section, whatever the cross section you want. Okay, and perform the shape force and minimum diagram, and you can correlate it with your hand calculations. Okay, so this is how you can able to learn how to solve the problem which you are solving in engineering, and how you solve, you can get the result, you can match the result with the answers. Okay, it is clear. Or you have any doubt in this session, you can ask me, I'll clarify your doubts. So what aspect ratio, ma'am? Ma'am, what aspect ratio you are asking for? Oh, okay. So in meshing here, we are, as of now, we are doing the automatic meshing, right? You can see that one dimensional elemental, we are not worry about the aspect ratio and all. Okay, in two dimensional only we have to check the aspect ratio, taper ratio, warping angle, all those things. Okay, so for one dimensional and all, we have to check the uh, joint only. So you can see that that's what I demonstrating here. In the geometry we have two lines, right? First line and two lines is there, and I convert this two line as a single beam itself. Okay, if you are not defining this joint, right, it look like a uh, T joint error will come. Okay, in most of the one dimensional problem, you just worry about the uh, junction of the each and every beam. You have to worry about these things. The two joint is not in that much problem. Whenever you have multiple joints, you have to look for that multiple joint connections. Okay, when you solve for a structural engineering problem like that, a civil engineering problem and all, uh, we are encounter lot of beams. That is not only two joints, there are multiple joints will be occurred while solving a truss problem, or not only truss, like a bridge problem and all. In one joint there are multiple connection will be there. So for that you have to give the end release. End release is the one condition you have to define for the beam element. For example, uh, so consider one line is from here and another line is here, and this type of beam is here like that. Okay, consider this type of beam floor connection is there. Okay, this is a pillar and this are the beams are connected in this way. Okay, so this beam have different cross section. For this, for as of now all the four beams are having a cross section is the rectangle one. Okay, at this junction what will happen means, for here also one box will be here, and here also one box will be here, and here also one box will be here. Okay, at this joint cross section will be connected towards these things, right? It will be messy over at this joint itself. You click closer over this, you can see that lot of joints are present here. It's kind of messy over here. So for this type of things in software, what you have to do is a end release. Okay, or while creating a 3D structure itself, nowadays that Ansys program is automatically calculate the end release. Okay, in previous version and all you have to worry about the end release. Now this now in latest versions you are not no need to worry about the end release and all. Okay, you whenever you created a three-dimensional structure and you are converting the 3D into 1D, the software itself automatically calculate the end release conditions. It takes the end release, so no need to worry about those things, ma'am. That aspect ratio and all you have to worry for the two-dimensional problem. Okay. uh, okay, so hope this class will be very useful for you. I think so. Like I suggest you to practice more. Like what are the problem you solve in your engineering classes, the same thing you can practice over here. Like you can create a different geometry over here. You can apply different cross section, and you can apply the simply supported beam or fixed support beam, or you can rather you choose the continuous beam also. uh, why? Because in engineering you are run into calculating structures 1, structures 2 and all. uh, Using Clapeyron 3 moment equation you are solving the continuous beam. For that you are supposed to draw the shape force and bending moment diagram. For even if you are in the third semester, you will be having a shape force and bending moment solid mechanics. For simple beam structures, simply supported or cantilever beam, you are apply the point load, or you can apply the uniform distributed, all those things you can apply here, and you can able to get those result also. Okay, for those beam you can able to calculate the shape force and bending moment diagram. Okay, if you want to apply the uniformly distributed load, here in static structural, in the insert force you can apply the pressure forces. Okay, instead of line pressure, right, you can apply the line pressure. You can click on this line, whichever the line you want to apply. In line you select this edges, and then you can apply the in component you can apply the load value. Okay, suppose that 110 newton per mm I am going to apply means, it is apply in upward direction. If you want to apply in a negative direction means minus 10. Okay, and see that in here you can see that 0 to 1 is happening, right? It is uniformly varying load. If you want to apply uniformly constant load means, in tabular data at point number 1 also you put minus 10. Okay, so now you can see the rectangular distributed load is applied over here, that is uniformly distributed load, UDL. If you want to convert UDV means varying load means, you can convert this is 0. Okay, that is uniformly varying load. From 0 it's starting with the maximum. If you want convert this is 0 and this is maximum means, you can vice versa. So you can convert this is minus 10 and you can put this is 0. So like that you can able to change it, and then you apply that condition in this beam and you can solve the problem. For that problem you can able to get the desired result for shear force and bending moment diagram. And even if you want to calculate the reaction about the each and every supports means, you can get it. Support also you can able to get it. Okay, so you try different problems, and if you have any doubt, or if you come across any problem means, you take the screenshot and send it to me. I will clarify in next classes. uh, till now you have any doubts, you ask me, then we'll wind up the classes. So no doubt so far. Okay. Okay, thank you all. We'll see you in next classes. Okay.